two intelligent species roamed the Earth tens of thousands of years ago, Neanderthals and Homo sapiens. Each was uniquely adapted to survive, but today only one species remains. What happened to the Neanderthals? Was it a matter of strength versus intelligence, or did sheer luck determine the outcome? This story of survival explores how both species navigated the harsh realities of their time and the legacy they left behind, which still resonates within us today. While Neanderthals and Homo sapiens had similar brain sizes, the structural and functional differences between their brains were significant. Research shows that Homo sapiens had an evolutionary edge due to the development of more neurons in the neocortex, particularly in the frontal lobe. This part of the brain is responsible for higher cognitive functions such as problem-solving, planning, and social interaction. A key factor in this difference was the TKTL1 gene, which, in modern humans, promotes the production of basal radial glial cells, progenitor cells responsible for neuron generation. This mutation is believed to have led to an increased number of neurons in the developing brains of Homo sapiens, giving them a cognitive advantage over Neanderthals. Neanderthals, although capable of tool use and complex social behavior, may have been more focused on immediate survival strategies, such as hunting and ambush tactics, rather than long-term planning. Their cognitive strengths lay in visual and motor functions, enabling them to react quickly to environmental challenges, but they may have lacked the abstract thinking necessary for creating symbolic language, art, or long-term strategies. Homo sapiens, by contrast, benefited from enhanced prefrontal cortex activity, a region of the brain involved in complex reasoning and foresight. This brain wiring enabled early humans to engage in future-oriented behaviors, like planning hunts, storing food, and forming long-term alliances. This cognitive flexibility also allowed Homo sapiens to adapt rapidly to environmental changes and coordinate larger social groups. Further studies suggest that differences in metabolic processes in the brain may have also played a role. The modern version of the TKTL1 gene stimulates specific metabolic pathways, increasing fatty acid synthesis and promoting neuron production in critical brain regions. This metabolic advantage likely contributed to the expanded cognitive abilities seen in Homo sapiens, further setting them apart from Neanderthals. In summary, while both species were intelligent and capable in their own right, Homo sapiens' advanced cognitive abilities, fueled by greater neuron production and enhanced brain metabolism, allowed them to excel in long-term planning, innovation, and social cooperation. This difference in brain function likely played a pivotal role in Homo sapiens' success and the eventual disappearance of Neanderthals. This insight helps explain why, despite their physical strength and adaptability, Neanderthals were eventually outcompeted by Homo sapiens and faded from the evolutionary landscape. Neanderthals had a robust build designed for raw strength, reflecting their physically demanding lifestyle. Their thick bones and heavily muscled upper bodies were adapted to the cold climates of Ice Age Europe, where they often hunted large game like mammoths and woolly rhinoceroses. Neanderthals also had shorter limbs and a broader pelvis, giving them a lower center of gravity that made them powerful grapplers. This body structure was ideal for close-range confrontations with prey and navigating the rugged landscapes of Europe. Scientific estimates suggest that the muscle mass of Neanderthals far exceeded that of modern humans. Their right arm dominance, reflected in the robust bone structure, implies repetitive use of heavy tools, spears, and other implements. These physical adaptations enabled them to perform tasks requiring explosive bursts of strength, such as taking down large prey animals and carrying heavy loads over long distances. In contrast, Homo sapiens developed a leaner frame and longer limbs, better suited for endurance activities such as persistence hunting, where prey is pursued over vast distances until it collapses from exhaustion. Their lighter build allowed them to move more efficiently over open landscapes, providing an advantage in migration and long-range travel. Additionally, the skeletal differences between the two species indicate that Homo sapiens were more efficient at dissipating heat, making them better equipped for warmer climates. Neanderthals' strength did not necessarily translate into greater physical superiority in all scenarios. While they excelled at short bursts of high-intensity activity, they lacked the endurance capabilities of Homo sapiens. These distinctions would have shaped their lifestyles, with Neanderthals focusing on ambush hunting and Homo sapiens relying on cooperative long-distance strategies. Moreover, the physical adaptations of Neanderthals reflect not only strength, but also their ability to survive in harsh environmental conditions. Their larger lung capacity and efficient respiratory system allowed them to perform strenuous activities in low-oxygen, high-altitude environments. This contrasts with the more generalist physiology of Homo sapiens, which favored versatility over specialization. Ultimately, the difference in physical form between the two species highlights how each was adapted to survive within its environment. Neanderthals were specialists, physically primed for the challenges of their cold, demanding world, while Homo sapiens were generalists, with endurance and versatility allowing them to adapt to a wide range of environments and climatic changes. This adaptability played a crucial role in Homo sapiens' long-term success and expansion across the globe. Neanderthals and Homo sapiens both developed sophisticated toolkits, but their approaches reflected different evolutionary strategies. Neanderthals were associated with the Mousterian industry, characterized by Levallois flaking techniques, which allowed them to produce sharp, efficient tools from prepared stone cores. These tools were highly effective for close-range hunting and processing animal carcasses, but the technology remained relatively unchanged for thousands of years, indicating that Neanderthals favored reliable, time-tested methods over innovation. Homo sapiens, however, ushered in a new era of technological advancement with the transition into the Upper Paleolithic period. They developed blade technology, which produced long, thin flakes that could be further refined into specialized tools such as knives, scrapers, and burins. Homo sapiens also began using materials beyond stone, including bone, antler, and ivory, to create complex tools like needles for sewing clothing and harpoons for fishing. This use of organic materials highlights their ability to adapt to different environments, as warm clothing and fishing equipment were critical for survival during cold glacial periods. A key feature of Homo sapiens' tool use was their ability to innovate and spread new technologies across large regions through cultural networks. This process, known as cumulative culture, allowed groups to build upon previous knowledge and pass it down across generations, accelerating technological development. In contrast, the Neanderthals' more isolated groups likely limited their opportunities for social learning, which may have slowed the spread of new ideas and tools. Some evidence challenges earlier assumptions about Neanderthal innovation. For example, recent findings suggest that Neanderthals may have independently developed pitch or tar for toolmaking, demonstrating their problem-solving abilities. However, these innovations were likely less frequent and regionally restricted compared to Homo sapiens, whose tools and ideas spread rapidly through trade and migration networks. The Upper Paleolithic toolkits of Homo sapiens not only served practical purposes, but also carried symbolic meaning, as seen in tools that were decorated or designed for ritual use. This dual purpose reflects a cognitive shift that emphasized both functionality and expression, an advantage that allowed Homo sapiens to thrive in changing environments and complex social structures. Ultimately, the ability to experiment, innovate, and transmit knowledge widely gave Homo sapiens a crucial edge over Neanderthals. While Neanderthals relied on consistent and effective tools suited to their specific environment, Homo sapiens embraced change and adaptation, ensuring their survival across a wide range of ecosystems and conditions. This capacity for innovation, combined with their social networks, was a key factor in Homo sapiens' long-term success. Some studies speculate that Neanderthals may have used vocalizations similar to songs or rhythmic calls, which could have facilitated emotional bonding or simple communication during group activities. This aligns with findings that Neanderthal speech may have included more consonant-like sounds, allowing for more efficient communication, although likely without the full complexity of modern human languages. In summary, Neanderthals possessed many of the anatomical and cognitive elements necessary for speech, but Homo sapiens took language to the next level with abstract symbolic thought. This difference may have provided a critical advantage, enabling Homo sapiens to build complex societies and share innovations across generations, while Neanderthals remained more limited in their social and cultural scope. The ability to communicate abstract concepts not only strengthened Homo sapiens' group dynamics but also laid the groundwork for the advanced civilizations that followed. Neanderthals and Homo sapiens both left behind traces of artistic expression, though the scope and depth of their creative efforts appear to differ significantly. Neanderthal art, though limited, includes geometric engravings, pigment use, and even decorative shells, indicating that they may have had some understanding of symbolism. Archaeological findings suggest that Neanderthals used ochre pigments, likely for body decoration or on objects, hinting at early forms of cultural expression or rituals. However, the lack of diversity in their artistic repertoire implies that art may not have played a central role in their society. In contrast, Homo sapiens experienced an explosion of artistic creativity during the Upper Paleolithic period. They left behind stunning examples of cave paintings, carved figurines, and ornate jewelry. Cave paintings found in places like Lascaux in France and Altamira in Spain depict a range of animals, hunting scenes, and abstract shapes, often painted deep inside caves, suggesting that these works held significant meaning, possibly for religious or spiritual purposes. The creation of figurines like the Venus statues, exaggerated representations of the female form, suggests that early Homo sapiens engaged in symbolic thinking, possibly linked to fertility, identity, or community cohesion. The use of art among Homo sapiens was not merely decorative, it likely served as a tool for social bonding and cultural identity. Art may have been used in rituals, storytelling, or to mark significant events within the community. This collective participation in artistic activities helped build social cohesion and reinforced group identity, fostering connections within and between groups. Some researchers speculate that Homo sapiens' ability to create and share symbolic art gave them an advantage over Neanderthals. The ability to express abstract ideas through art could have strengthened their cultural identity and enabled more complex social interactions. Additionally, art and ornamentation may have served as a way to signal group membership, wealth, or status, which could have facilitated alliances and cooperation between different groups. Although there is evidence that Neanderthals engaged in artistic activities, their art lacks the complexity and diversity seen in Homo sapiens' creations. This difference suggests that while both species had the capacity for creativity, Homo sapiens placed a greater emphasis on symbolism and expression as a fundamental part of their culture. This focus on art and culture may have contributed to their ability to build stronger social networks, share knowledge, and adapt to new environments. Ultimately, the artistic legacy of Homo sapiens continues to shape the way humans express identity and connect with one another. The cultural emphasis on symbolism, storytelling, and shared experiences laid the foundation for many of the practices that persist today, from religious rituals to the arts. In contrast, the simpler artistic expressions of Neanderthals remind us that, while they shared some aspects of creativity with Homo sapiens, they followed a different path, one that left behind fewer, though no less intriguing, traces of artistic identity. Neanderthals primarily lived in small, tight-knit family groups, likely made up of around 10 to 15 individuals. Fossil evidence shows that these groups often included members with injuries or disabilities, suggesting that Neanderthals had a sense of compassion and caregiving. For instance, remains of individuals with severe injuries, such as broken bones that had healed, indicate that these people were cared for by their community, even when they could no longer contribute to the hunt. This points to a level of empathy and emotional bonding within Neanderthal groups, reinforcing the importance of close relationships in their social structure. However, the small size and isolation of Neanderthal groups may have posed challenges. Studies suggest that inbreeding was a common issue, likely due to the limited population size and reduced intergroup contact. Genetic evidence indicates that Neanderthals had lower genetic diversity than Homo sapiens, which might have made them more vulnerable to environmental changes and diseases. In contrast, Homo sapiens thrived by building large, interconnected networks. These networks spanned regions, facilitating the exchange of goods, tools, and ideas. Social bonds were not limited to immediate families. They extended to alliances with distant groups, allowing for the sharing of resources during times of scarcity. These connections made Homo sapiens more resilient, especially when environmental conditions changed, by ensuring access to food, tools, and knowledge through trade and cooperation. Homo sapiens' ability to organize ceremonial gatherings and rituals also helped solidify social bonds across larger communities. Rituals, such as burials and symbolic art, provided a sense of belonging and cultural identity that extended beyond small family units. These practices may have reinforced alliances between groups and helped maintain social cohesion over long distances. Neanderthals likely lacked the capacity to form and sustain such complex networks. While they displayed compassion within their small groups, their social isolation made it difficult to exchange knowledge or adapt quickly to new challenges. Homo sapiens, by comparison, used their expansive networks to rapidly spread innovations, such as improved hunting techniques and tools. This difference in social structure played a critical role in the survival and expansion of Homo sapiens. As small Neanderthal groups became more isolated, Homo sapiens flourished through cooperation and cultural exchange, forming the foundation for the global societies we know today. The Neanderthal way of life, though deeply connected within families, was ultimately outpaced by the adaptive and collaborative networks of Homo sapiens. This comparison reveals that while close-knit groups offer emotional support, large-scale cooperation is often necessary for long-term survival and progress. Neanderthals were specialists, thriving in cold climates and harsh environments. Their bodies and skills were optimized for survival in Ice Age Europe, where they relied on close-range hunting and stable environmental conditions. Neanderthals developed robust physiques, excellent for power-intensive activities like ambushing large prey, and used tools suited for repetitive tasks. However, this specialization made it difficult for them to adapt when environmental conditions changed dramatically toward the end of the last ice age. Homo sapiens, by contrast, were generalists. They developed technologies and behaviors that allowed them to thrive in a wide variety of ecosystems, from African savannas to frozen tundras. The ability to craft diverse tools, like bows, nets, and spears, enabled them to hunt different prey and forage across various terrains. This flexibility extended beyond hunting. They were also able to engage in seasonal migrations and form social networks that spanned large geographic areas. The success of Homo sapiens as generalists can also be attributed to their cultural adaptability. They exchanged ideas and tools between groups, allowing innovations to spread quickly. This ability to cooperate and share knowledge made Homo sapiens more resilient during periods of environmental change. For example, as the climate warmed and large Ice Age mammals became scarce, Homo sapiens shifted toward fishing and gathering, while Neanderthals struggled to move beyond their traditional hunting strategies. Migration into Europe exemplifies this difference in adaptability. When Homo sapiens arrived, they faced unfamiliar ecosystems and new challenges, but their diverse toolkit and flexible social structures allowed them to adjust. Neanderthals, despite their strengths, were less adaptable, and their populations began to dwindle as they were outcompeted for resources. Ultimately, this distinction between specialists and generalists highlights how Homo sapiens' ability to innovate, migrate, and form networks made them more adaptable to environmental shifts and unpredictable events. It also suggests that, while specialization offers short-term advantages, generalism may be a better strategy for long-term survival. Modern humans carry 1 to 4% Neanderthal DNA, a genetic legacy that has influenced not just our immune responses, but also various physical and psychological traits. This interbreeding, which occurred around 40,000 to 50,000 years ago, provided Homo sapiens with critical adaptations as they migrated into unfamiliar Eurasian environments. One of the most significant advantages inherited from Neanderthals is immune function. Neanderthal genes helped early humans fight off new pathogens encountered in colder climates. These genes also conferred resistance to RNA viruses, including strains that today affect us as influenza, HIV, and hepatitis C. However, some of these traits come with downsides. For instance, hypercoagulation, which was once beneficial for wound healing, now increases risks for stroke and pulmonary embolism in modern humans. Neanderthal DNA has also shaped skin biology. Genes that regulate keratinocytes, which protect against ultraviolet radiation, are still active in modern populations, particularly among people of European and East Asian descent. However, these genetic traits can also increase the likelihood of sun-induced skin conditions, such as keratosis. Additionally, variations linked to circadian rhythms, our internal biological clock, are thought to have helped early humans adapt to longer nights and shorter winter days in northern latitudes. These same variants are now associated with being an early riser or adjusting easily to seasonal changes. Surprisingly, researchers have found links between Neanderthal DNA and mental health conditions. Some genetic variants may increase susceptibility to depression and other psychiatric disorders. This discovery underscores the complexity of integrating traits from a species that evolved along a different path. While some genes conferred benefits for survival in ancient times, they may now pose risks in the modern world. The disappearance of Neanderthals is one of the most intriguing puzzles in human history. There is no definitive answer, but it's likely that multiple factors, climate change, competition, disease, and interbreeding, contributed to their decline. The end of the last ice age brought about significant environmental changes that disrupted ecosystems on which Neanderthals depended. As prey populations shifted and food sources dwindled, Neanderthals struggled to adapt their specialized hunting methods to the new conditions. Meanwhile, Homo sapiens, with their diverse toolkits and social networks, were better equipped to navigate the changing landscape. One theory posits that competition for resources between the two species played a key role. As Homo sapiens expanded into Europe, they would have occupied hunting grounds previously dominated by Neanderthals, leading to increased competition. However, evidence suggests that encounters between the two groups were not purely hostile. Instead, interbreeding occurred, with genetic traces of Neanderthals still present in modern human populations today. This suggests that the two species coexisted and may have even formed cooperative relationships at times. Another contributing factor could have been disease transmission. Neanderthals had evolved in Europe and were likely vulnerable to new pathogens carried by Homo sapiens, migrating from Africa. Some researchers propose that the introduction of diseases to which Neanderthals had no immunity could have accelerated their decline, similar to how European diseases devastated indigenous populations in the Americas during the colonial period. The blending of Neanderthal genes into modern human genomes indicates that extinction was not sudden, but rather a gradual process of assimilation. Interbreeding may have allowed some Neanderthal traits to persist, even as their distinct population faded away. Genetic evidence shows that Neanderthals contributed genes involved in immune responses, metabolism, and even neurological traits to modern humans. However, as Homo sapiens populations grew and spread, Neanderthal genetic contributions became increasingly diluted over generations. This gradual fading challenges traditional notions of extinction. Instead of vanishing overnight, Neanderthals merged into the Homo sapien gene pool, leaving an indelible mark on modern humanity. In many ways, the legacy of Neanderthals lives on, not just in our genes, but also in the shared history that connects us across time. The extinction, or assimilation of Neanderthals, invites us to reflect on the complex interplay between survival, adaptation, and coexistence. Was it a tragic end for a resilient species, or a natural evolution towards something greater? Either way, the story of Neanderthals reminds us that extinction does not always mean disappearance. Their legacy continues, subtly influencing who we are today and offering a poignant reminder of our shared origins. The story of Neanderthals and Homo sapiens is more than a tale of survival. It is a reflection on what it means to be human. The success of Homo sapiens was driven by adaptability, social bonding, and imagination. Yet, the legacy of the Neanderthals endures, reminding us that extinction is not always the end.